All right, today we're going to learn about the law of sines. The law of sines at its basic level basically says that if in a triangle you take an angle measure and the sine of that angle and put it over the length of the side opposite that angle, that it will be proportional to every other angle and side pair. So the first thing I do when I'm thinking about the law of sines is I make sure I know where everything sets up. So if I have an angle A in my triangle, then I label the side opposite it with a lowercase a. If I have a B, the opposite side is going to be lowercase b. What do you think the side opposite angle C would be labeled as? Lowercase c. And so once you know how it's all set up, then this will always hold true. The sine of A over A is equal to the sine of B over B is equal to the sine of C over C. A, B, and C are angles. Little a, little b, and little c are side lengths. Does that make sense? The little ones are the lowercase letters are the lengths of the sides. And the uppercase letters are the vertex points, so we use them to reference the angles. Is everybody okay with that? Nothing earth-shattering there. So basically what I'm saying is, if I know any angle and its opposite side pair, and then any one other piece of information, I can solve the rest of the triangle. Let's see how that works. So here we've got triangle ABC. So I'm going to go ahead and sketch out triangle ABC. Now this triangle is not going to be drawn to scale, because I'm not going to take the time to measure out any angles or anything like that. I'm just going to do a rough sketch. It said that angle B was 93 degrees, so I'm going to put the B at the biggest place, the A over here, and the C over here. So if this is angle A, where do you think side A would be? Yeah, side A is representing the length of BC. Where would side little b be? On the bottom. And where would C be? The only one left. Now, in this particular problem, we're not going to work with angle C and little c. But I'm going to go ahead and extend the problem a little bit, and I'm actually going to solve for all the missing values in the triangle. And I'm going to do this using the law of sines. And the law of sines says that the sine of angle A over, what do you think it's over? Little a is equal to the sine of angle B over little b is equal to the sine of angle what? Over little c. All right, what do I know? I know that angle A is 48 degrees. And I know that angle B is 93 degrees. And I know that the length of AC is 15. Well, AC is the same as what? B. So because I have the information from both angle B and side B, I will definitely be using that ratio in finding my answers. All right, so here we go. Let's find the length of BC, which is the length of little a. How would I set it up? It's the sine of A, and A was what? 48 degrees. It's the sine of A, which is 48 degrees, over, we don't know what A is, that's what we're trying to find. And that's equal to the sine of B. What was the measure of B? 93 degrees over 15. What's the first thing you do when you're dealing with a proportion? How do you solve if one of the values is unknown? Cross multiply. That bad boy times that bad boy. All right, so when I cross multiply, here's what I get. I get A times sine 93 degrees is equal to 15 times sine 48 degrees. What do I need to do to isolate A? That's right. You undo multiplication by using division. So if I divide both sides by sine 93, then they'll cancel there. So that's going to leave me with A is equal to 15 times sine 48 degrees over sine 93 degrees. Now, all I need to do is put that in my calculator and I can get the final answer. Now we're kind of getting to a level where putting stuff into your calculator is getting just a little bit tricky. Larson, you got a question before I go on to calculator use?
Can you not cancel out sine?
No. The sine is not a variable, it's a function. So it would be like trying to cancel out the square root of 13 over the square root of 93 or something like that. You can't just cancel out the square root symbol. You can only cross-cancel things that have been multiplied. But that's a good question. All right, so let's take a look at how to use my calculator. I'm going to demo off of the calculators that I have that are classroom set calculators. Is that too dark? Can we see that okay? All right, I can make it a little bit lighter. How's that? All right, so the problem was 15 sine 48 divided by sine 93. Now, multiplication and division have the same level of priority, and they just work from left to right. So I can put all of these things in from left to right, and it will be okay. However, in most calculators that you guys have, when you enter in a trig function, it automatically opens up a parentheses. And if you don't close that parentheses, then everything inside after that first parentheses is being taken the sine of. So I don't want to accidentally take the sine of 48 times the sine of 93. I want to take the sine of 48 first, be completely done with that, and then take the sine of 93 after I've divided. So I'm going to be careful about how I enter it on my calculator. So it was 15 sine, notice it opens up a parentheses. When I type in the 48, I need to close that parentheses. And then division, and then the other one was what, sine 93? 93. Doesn't matter whether I close that one or not because I'm getting ready to be done, but I'll just close it just for consistency. And I get 11.16. So make sure that you can type this problem in on your calculator and get 11.16, which I'm going to round off to 11.2.
Mr. Baker?
Yes.
Even on my calculator, when I did it the first time before you told us all that, I got the same thing without closing the parentheses.
Okay. I mean, your calculator might work a little bit different than mine. Are you sure?
Yeah.
Does it auto-close your parenthesis for you? Are you hitting enter in between any of the times? I mean, there could be a lot of different variables that are happening. So I'll work with you individually if we have time. All right, so by the way, that's the answer to the question. I can also find angle C and little c. How do I find angle C? All right, the measure of angle C is going to equal 180 minus 48 plus 93. So if I do that on my calculator, I'm just showing you how to use parentheses on your calculator now so that you can avoid errors. 180 minus parentheses 48 plus 93, close parentheses. It's 39. The missing angle measure was 39 degrees. And so now that I know that angle C is 39 degrees, can't I do sine of 93 over 15 is equal to sine of 39 over C? And then if I cross multiply, that's C sine 93 equal 15 sine 39. Oh, wow, that's not going to mess anybody up that they're backwards like that. And then C is equal to 15 sine 39 over sine 93. So I would type that into my calculator. How's that going to work going into my calculator? It's going to look like this. 15 sine 39, close the parentheses, divided by sine 93. And Caroline, your calculator, when you hit the new trig function, might auto-close the parentheses. So that's going to be 9.5 when I round off. So I go back and put 9.5 here. So let's think about this for a second. 9.5 was this side, 11.2 was this side, and 15 is this side. Is the biggest side opposite the biggest angle?
Yes.
Is the smallest side opposite the smallest angle?
Yes.
Isn't that neat how that worked out? All right, so that's how you use the law of sines when you have two angles and one of the sides opposite one of the angles. You can find out everything else. Now, there are other situations which you might have. I'm going to skip this practice and go on to this. In this particular triangle, when I draw this one out, I'm going to draw a triangle, and this one's an obtuse triangle because it's got a 120-degree measure in it. That's you. In this particular triangle, triangle RST, now you've got two sides in an angle, RST. Okay, and we know that the measure of angle R is 120 degrees, and we know that RT is 11, and we know that ST is 18. Okay, can we find the value of angle S? So here's what I'm looking for. I'm going to label this X. Well, do I know the side opposite X? Sure. So I know this and this, but I also have this and this. So my setup is using the law of sines would be sine of S, which is X, over its opposite side, which is 11. So here's the angle. Here's the opposite side. The angle goes with the trig function. And then the other side would be sine. Sine always goes in top. Sine R, which is 120 degrees, over, what's the opposite side to the 120? 18. So now this is going to get a little tricky, but when I cross multiply, that's 18 sine X equals 11 sine 120. How do I isolate X? I'm going to start out by dividing both sides by 18. So when I divide by 18, that gives me sine X is equal to 11 sine 120, all of that divided by 18. But I still haven't isolated X yet, have I?
So I do the inverse.
So how do you undo a trig? You use the trig inverse. So see, nothing really new here. It just gets kind of, there's a lot of moving parts to it. So when I do sine -1 of sine, that's what cancels the sine out. And you will be left with what you're going to put in your calculator. X is equal to sine inverse of all of that stuff. 11 sine 120 degrees over 18. I don't like my degree symbol. Make that a little bit better. 120 degrees. Those parentheses. Now, how do I put this into my calculator? Well, the first thing I'm going to do is I'm going to put in the sine inverse. So sine inverse automatically opens up, oops, I did sine. Sine inverse automatically opens up a parentheses. Okay? And then inside the sine inverse, I want to do 11 sine 120. So I do 11 sine 120. I need to make sure I close up 120's parentheses. And then divided by 18. So I can do division 18. Then I'll close up the sine inverses parentheses. And when I hit enter, I get 31.9. Usually with degrees, we round them off to the nearest whole number, so that'll be 39.2. So the value of x is equal to 32. I said 39.2, but it should be 32.0 degrees. So if I know this degree, now I can find this degree, and then I can find the other side. Tayana, you okay with all this? I guess not. Other questions? All right. I think I got time to do one more. All right. So let's take a look at a word problem. Okay. A ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Cove Town Lighthouse are located 40 miles apart at sea. The captain cannot determine the distances by observation. The triangle formed by the lighthouses and the ship is shown. Can the ship sail safely to either lighthouse? So he can definitely sail. Well, which side do you think would be shorter? Yeah, this is probably the shorter distance, right? How do we know it's the shorter distance? It's opposite the shorter angle. So let's find this length right here. Now, what do we need? We need, obviously, sine 52 over x is going to be one of our things. I need to have another angle that's opposite this side. So I need to go ahead and compute this angle right here. Well, this angle is going to be 180 minus 70, which is 110. And 110 minus 52, which is 58. So that angle is actually 58 degrees. I computed that. And so now I can use sine 58 over 40 as my other proportion. Is everybody with me? All right. So I'm going to cross multiply, and I'm going to get 40 sine 52 equals x sine 58. Then I'll divide both sides by sine 58, and x is going to equal 40 sine 52 divided by sine 58. Now it's time for the calculator to see if we're less than 40. So I go over to my calculator, and I punch in 40 sine 52. Make sure I close off that parentheses. Divided by sine, what was it, 58? I think it was 58. And I get 37.16. We'll round that off to 37. And the answer will be yes, it can make it to port. You could also compute this other side and find out whether it can make it to that one or not. All right, homework tonight. Make sure that